Welcome all to the Max lecture series. Of course, we are learning entire concepts only through problems. We are in mean values theorem. In the last class, we saw how Rolle's theorem failed. So, we have to verify three conditions. Let us continue with that. Let us take one more question. Once again, you have to verify the Rolle's theorem for this question also. Just verify Rolle's theorem. Take Rolle's theorem and verify it. What is the step number 1? You have to take the given function and check whether the given function is continuous or not in the given interval -3, +2. But as I already told you that always all polynomial functions are continuous and derivable also, that is differentiable. Okay sir, so this given function is always continuous. Let us take the second condition. It should be differentiable in the open interval of -3, +2. Did you observe the difference? In the same question, last time I have taken the interval of -2, +2. But in this case, I am taking -3, +2. That's all. Only thing is I have changed the data. Fine sir. Anyway, it is continuous and differentiable. But we have to moving on to the third point. Third point means you have to identify the value of f of 3 and you have to identify the value of f of 2. It means interval is always given. In the interval, we will be having 2 points. Identify the given function value in the given 2 points. Check whether they are equal or not. Now, when I am checking the value of f of -3, what you will be getting? -3 whole square plus x will be replaced by -3. See there, x square plus x will be replaced by -3. Here we will be having -6. -3 whole square will give you +9. -3 -6 will give you -9 will be equal to 0. Now check the value of f of +2. If I am taking the same function, +2 will give you +2 whole power 2 plus x will be replaced by 2 -6. You know 2 square will give you 4 plus 2 -6 equal to 0. Now check whether the value of f of -3 equal to f of +2 or not. Yes sir, they are equal. See there, if you observe them carefully, they are equal to each other or not. Both values are yields to 0 only. Sir, the third condition also satisfied in the given function. So, if Rolle's theorem is satisfied these three conditions, next step what you have to do is nothing, just take the function f of x equal to x power 2 plus x minus 6. Just differentiate the function once, then you will be getting f dash of x, that will give you 2x plus 1, and then equate this function to 0. What I am doing? Take the function, differentiate once, equate it to 0, then what you will be getting? If I am equating it to 0, then the value of x will become -1/2. Check whether this function or whether this value is lies between the given interval or not. See there, -1/2 is lies in between -3, +2 only. So, Rolle's theorem is successfully verified. Yes, according to Rolle's theorem, whenever your Rolle's theorem is satisfied these three conditions, like it should be continuous in closed interval, it should be differentiable in the open interval, then the given intervals, there are 2 points in the given interval, you have to find out the value of the function in the 2 interval values. After that, you have to cross check whether they are equal or not. If these three conditions are satisfied, then definitely there will be one point exist between the given 2 interval. So, that is what we are checking. So, if these three conditions are satisfied, then according to Rolle's theorem, between the given interval, there will be one point will exist. How to identify that point? You can identify that point just differentiating this function and then equate it to 0. Actually, while equating it to 0, we are specifically focusing on a particular point. Particular point means we can treat that point is C. So, sometimes what people will do is they are replacing the x by c, because x is y-axis value. For x we can keep a, b, c, d, e, f, g, anything. So, here I am particularly focusing one point, that point lies between the given interval. In order to focus on only that particular point, x will be replaced by c. So, people will be writing the answer is c is equal to -1/2. That point is lies within the given interval according to Rolle's theorem. So, that is how we are traveling along with the Rolle's theorem. I hope you all understood. So, this is the standard procedure. Check three conditions. If any one condition is failed, then Rolle's theorem will not exist. You can say Rolle's theorem is failed to exist for the given function. So, this is all for this lecture. Remaining things we will see in the next class. Thank you all.